next problem on the Newton forward, Newton backward, and Lagrange's interpolation formula. So problem is what? Find the 10.12 and 10.26 from the following data. So what are given? The values of x are given, and the values of y or fx, that is tan x, are given. And these point 10, point 15, point 20, point 25, and point 30 are equidistant. And so we can apply Newton's forward, Newton's backward, as well as Lagrange's interpolation formula. But when we apply Newton's forward interpolation formula, if the values are equidistant, and we have to interpolate near the beginning of table. So this point 12 is here at the beginning of the table, and therefore to find the value at 10 to find the value of 10.12, we are going to use Newton's forward interpolation formula, and this 0.26 is at the end of the table, and therefore we are going to use Newton's backward interpolation formula to find 10.26. So the values of x are equidistant, and this value is beginning of the table, so use Newton's forward interpolation formula. This value 0.26 at the end of the table, and therefore use Newton's backward interpolation formula. If these values of x are not equidistant, then use the Lagrange's interpolation formula. So if the value is the values of x are suppose equidistant, and we have to interpolate at the middle of the table, then use Newton's forward interpolation formula. So when we use the Lagrange's interpolation formula, if the values of x are not equidistant, otherwise if we have the choice of applying formula, then we use Newton's forward or backward if the values of x are equidistant. So we construct the forward difference table. We will find the value of 10.12 first, and so we are going to use Newton's forward interpolation formula to find 10.12, and therefore prepare a forward difference table. So this is the forward difference table. This first column is what? First row, second, that is the values of x. The values of y is the second column, and the third column is del y, delta y, delta square y, delta cube y, delta raised to 4y. And what are the entries? This minus this at this place, and this is what? Actually, this is a, this is a, this is f of a, this is delta f of a, this is delta square f of a, delta cube f of a, and this is delta raised to 4 f of a. And then write the Newton's forward interpolation formula. Before that, find the value of u. Instead of p, write u. What is u? First x minus first value of x, that is a, divided by h. And so x is what? 0.12. That is where to find the value at 0.12. So x is 0.12, and x naught, that is a, the first value is what? 0.10. The value of x, first value of x is what? 0.10. So a is 0.10. So right here, instead of x naught, write a, 0.10, and h is what? 0.05. That is the common difference, the difference between the values of x. So the values of x are 0.10, 0.15, 0.20. The distance is what? 0.05. So h is 0.05, and therefore u, right here u as x minus a by h, and the value is 0.4. And then write the Newton's forward difference formula, forward difference interpolation formula, that is fx. Right here, instead of y as f, fx is equal to f of a plus u delta f of a plus u minus 1 by 2 factorial delta square f of a. So right here u in place of p, and where why not write f of a, here is f of a. So write the terms up to delta raised to 4 f of a. That the next term is what? The p, that is u minus 1, u minus 2, u minus 3 divided by 4 factorial delta raised to 4 f of a, and then substitute the values. So what is f of a? That is y naught. From table, it is this 0.1003. This is delta of f of a, that is this value, delta of f of a is 0.0508, and substitute all those values. Substitute the value of u and all the values of this f of a, delta square f of a, and find the answer. The answer is what? 0.1205. This is 10.12. 10 of this 0.12 is this, and we can also tally this answer by using calculator. We can find the answer by using calculator. That is, convert the calculator to radian, because this 0.12 is in a radian. So convert the calculator to radian and find 0.12, and so this answer uh, we can tally with by using calculator. Okay, and then we have to find the 10.26. So we are going to use the Newton's backward interpolation formula. So first find p. What is p? X minus last value of, that is here is the notation xn, but we use the notation a plus nh. So what is the a plus nh? Means last value. And what is the last value of a plus x? Is 0.30. So what is u? That is 0.26 is the value of x, because we have to find the value at 0.26. So right, x is 0.26, and then a plus nh is what? 0.30 divided by h is 0.05, and this is u. And then write the formula, that fx is equal to f of a plus nh instead of yn, f of a plus nh. So this is u del of f of a plus nh, u plus 1 by 2 factorial del square f of a plus nh, u plus 1 u plus 2 by 3 factorial del cube f of a plus nh. And the next term is what? u plus 1 u plus 2 u plus 3 divided by 4 factorial del rest to 4 f of a plus nh, and then substitute the values. So what are the values of f of a plus nh? So from table. So this is actually forward difference table, but what is the difference between forward difference table and backward difference table? The entries are same in the backward difference table and forward difference table. Only the change is at this place. That is, there is here is delta. So in backward difference table, it is del square, del cube. So these entries are same in the table, and so we are going to use this. So it is a plus nh. This is delta. This is f of a plus nh. This is delta del of f of a plus nh. This is del square f of a plus nh. Similarly, this is del cube f of a plus nh, and this is del rest to 4 f of a plus nh. So substitute these values in this formula, in the Newton's backward difference interpolation formula. We get this answer. We get this answer. So this is u, our u. So write here instead of p as u, and convert the problem in our notation. The answer is same, that 0.2662. We can also tally this answer by using your calculator. So next problem, find the cubic polynomial in x for the given data using Newton's forward difference interpolation formula, and hence find y6. Then find y6. So we have to fit the polynomial to this data by using Newton's forward difference interpolation formula. And if you observe the values of x, then values are equidistant, and that's why we can apply Newton's forward, Newton's backward, as well as Lagrange's. But here the instruction is what? Use Newton's forward difference interpolation formula. So if the values are equidistant, that's why we're going to use the Newton's forward or backward. But here the instruction is what? Use Newton's forward difference interpolation formula. So first construct the forward difference table. What is the forward difference table? The values of x as the first column, the values of y as the second column, then delta y, delta square y, delta cube y. And if you observe the entries in the delta cube y, all the entries are same, and therefore no need to find the further columns. And then x naught, here write a, our notation a is 0. That is the first value of x. H is common difference, 0, 1, 2, 3 difference is 1, and therefore u is what? X minus a divided by h, that is x. So substitute x as x, because we have to find the polynomial which takes these values, and therefore substitute x is equal to x. And then write the Newton's forward difference formula. Write this Newton's forward difference formula in the our usual notation, that fx is equal to f of a plus u delta f of a, u minus 1 by 2 factorial delta square f of a, and substitute the values of these delta f of a, delta f of a from the table. So these are the values. This is a, this is f of a, this is delta f of a, delta square f of a, delta cube f of a. So all the remaining terms are equal to 0, and find the answer. So we have this answer, x cube minus 2x square plus 7x minus 3. So this is the polynomial which fits to this data. And how we can tally your answer? Substitute x in this polynomial. Substitute x is equal to 0, we get answer minus 3. Substitute in the answer x is equal to 1, we get answer 3. If we substitute 2, 11. In this way, if we substitute 5, then we get answer 107. And so we can also tally your answer. And then the further question is what? Hence find y6. So how you can find y6? Y6 by substituting x is equal to 6. We get the answer 183. The next problem, find the cubic polynomial in x for the given data. So again, the problem of fitting of polynomial, and the data is what? Given in this form, y1 is equal to 24. Or instead of y, use notation f. f1 is equal to 24, f3 is equal to 120, f5 and f7, these are given. So what are the values of x? 1, 3, 5, 7. Values are equidistant. 1, 3, 5, 7. The distance is 2. That is h is 2. And these are the values of fx or y. This is f of a. This is f of a plus h, a plus 2h, a plus 3h. Okay. So the first we construct the, we are going to use the Newton's forward difference interpolation formula, and therefore construct the forward difference table. The first column is the values of x. The entries in the first column are values of x. What are that? 1, 3, 5, 7. So instead of the table, these data are given in this form. So what are the values of x? 1, 3, 5, 7. And what are the values of y or fx? 24, 120, 336 and 720. And then find delta y, delta square y, delta cube y. And this is the forward difference table. Then x no, a, what is a? A means the first value of x is a, 1, and h is what? 2. The common difference is 2, and therefore write u as x minus a by h, and therefore we have this answer. Substitute x is equal to x, because we have to find the polynomial which fits to this given data, which takes the given values of y, and therefore write Newton's forward difference interpolation formula, that in our notation fx is equal to f of a plus u delta f of a and the remaining terms, and substitute the values. And we are going to use the values these 1, 24, 96, 120, 48 in at this place. Okay, and then we have this answer, x cube plus 6x square plus 11x plus 6, and we can tally this answer by using substituting x is equal to 1, we get answer 24. If we substitute 3 in this x in this polynomial value of x as 3, then we get the answer 120. If we substitute x is equal to 5, we get answer 336. If we substitute 7 in this answer, then we get answer 720. And so the further question is hence find y8. So y8, substitute x as 8, and we get the answer 990. So this is the problem of missing term. Find the missing term in the following. This is the missing term, that is the value of y or fx corresponds to 3 is missing. So how many values are given? 1, 2, 3 and 4. So first sentence is 4 values are given, and therefore delta raised to 4 f of a, f of x or f of a is equal to 0. Either write here notation y0 or f of a, and then substitute delta as e minus 1, and then here is f of a or f of x, write f of x, here write f of x instead of y0, f of x. So and e minus 1 raised to 4 by using binomial theorem, the expansion contains total 5 terms, 1, 2, 3, 4 and 5 terms, and the terms are having sign plus minus plus minus plus. Okay, and this is right here, instead of y0 write fx, and then multiply by fx, and e raised to 4 fx is what? F of x plus 4h, because the difference is what? 1, 2, 3, 4, 1. Then write all the remaining values and substitute x is equal to 0. We get the equation, and we get the value of that f of 3, and this is what? the value is 31. Here the missing value is what? 31. So solve this problem by using notations that are used in the previous problems. Then next is what? Find y5 and y6. So this is the series. Actually, this is the series. Its first term is 9. Second term is what? 18. Then 20 and 24. That is, we are given 1, 2, 3, 4 terms of the series, and we have to find the fifth term of the series, sixth term of the series. And this problem is same to this problem, the previous problem. This is the problem of series. So here we are given the series 2, 9, 28, 65, 126 and 217. That is, we are given how many terms? 1, 2, 3, 4, 5, 6 terms. And we had, the question is what? Find 7th term or find 8th term. So this is the question in the example 2.22. And this problem, the current problem, is also same to that problem, that we have to find the y5 means what? The fifth term, and y6 means the sixth term. So what are given? The 4 terms are given, 1, 2, 3, 4, and we have to find the y first. How we can find y5? First find y4, then y5, and then y6. So this is the table, forward difference table. The forward difference table, we are going to use the forward difference interpolation formula. And what are the values of x? X are 0, 1, 2, 3. So these are the values of x. And what are the values of y or fx? 9, 18, 20, 24. And then delta y, delta square y, delta cube y. And now we have to find the value at 5. So x is what? X is 5. So what is x? X is, take x as 5. X as 5, and then find value of u, that x minus a, that is x minus 0, divided by x is 5 and a is 0, divided by h. H is common difference is 1, and then find the value of u and write the forward difference interpolation formula, Newton's forward difference interpolation formula, and substitute the values. And this is a, this is this is the f of a, this is delta f of a, delta square f of a, delta cube f of a. Substitute all these values, we get the answer y5, that is the value of y or fx at 5. Similarly, substitute x as 6 and repeat all the process, we get the value at 6. So by using Newton's forward difference formula, find these values. Actually these values are at the end of the table. So instead of this Newton's forward difference formula, use Newton's backward interpolation formula. So here prepare the backward difference table instead of this forward difference table. So just write here delta as a del, here write del, and here write del. Okay, and then use these values, a plus nh, f of a plus nh, and all these values. So write Newton's backward difference formula. Write Newton's backward difference formula and then substitute the values, we get the answer. So next problem, construct the forward difference table for the following set of values and compute the table to obtain f6 and f7. So what are the values of x? X are -1, 0, 1, 2, 3, 4, 5. Here write 4. Here, here the entry is 4, then 5, 6, 7. And compute the table to find f6 and f7. So we have to find the f6 and f7 by using table, from table. Otherwise we can use Newton's forward difference formula or Newton's backward interpolation formula. Actually, the values of x are -1, 0, 1, 2, 3, 4, 5 are equidistant, and we have to find the value at 6 and 7. So we use Newton's backward interpolation formula, or here is the question is compute the table to find. So by using table, we are going to find the value of f6 and f7. That is the values of this fx corresponding to 6 and 7. And if we substitute x is equal to 6 in this formula, then we also have the value of f6. But the question is compute the table to obtain f6 and f7. That is, we have to find the value of f6 and f7 not by using this formula, by using table. And so here is construct forward difference table. So this is the forward difference table. The values of x, and the values of x are continued up to 7. So first these entries are what? We have to find these values 2, 3, 9 and 3, 3, 7, 1. These are not given actually. And what is the value entries in the second column? The values of y or fx are what? That is substitute -1 in this formula. We get the answer -13. Then 0, we get answer -7 on all these. So these values are to determine corresponding to 6 and 7. So only just write the values table up to 5. First write table up to 5, and then prepare this forward difference table. And if you observe the third, this delta cube column, then all the entries are 6. Therefore here we have the entry 6. And when we have here entry 6, if this place is 30, 30 minus 24 is 6, and therefore here write 30. And then here is also 6. Therefore when we have here 6, if this entry is 36, so here is write 36. Then here is 44, and when we have answer 24, if this entry is 66, because 66 minus 44 is 24, and here is answer 30. Therefore 96 minus 66 is 30. Here is answer 30, 30, 96 minus 66 is 30. And when we have 36 answer, if 32, 130, at this place the number is 132, entry is 132, because 132 minus 96 is 36. And so similarly we have 66 if here is the entry is 143. This is given, but here how we can find this entry? When we get answer 96, if this entry is what? 239, because 239 minus 143 is 96. Similarly, when we have answer 132, if the entry is 371, so 371 minus 239 is 132. And in this way we have the answer f6 and f7 are 239 and 371 from this table by using table. That is not by using the Newton's forward difference formula or Newton's backward difference formula, or not by using this formula given in the problem. This is actually answer of this problem, y5 and y6. So how we can find y5? This is by using the this is another method, but we use this method, forward difference method or backward difference method. And these are some exercise of the problems for homework. So solve all these problems, and the answers are given at the end of exercise. So solve all these problems, and these are the problems on the Newton's forward difference formula, Newton's backward interpolation formula, and Lagrange's interpolation formula. So solve all these problems. Answers are given at the end of this exercise. So solve all examples and share on our common WhatsApp group answers of all the homework